Hello. Monica, is that you with my name? I'm so sorry. I guess I sent the link to you with my name by default. But no worries, you can change that name. Hello? Yeah, I guess there's another person with my name as well. Who is that? Is that Monica or someone else?
I just click on the link and join the session.
Yeah, Monica. That was link that was sent to me. So I forwarded the same link. That's why the name changed. But no worries about that. No issue about that. I hope you're able to hear me and you're able to see the screen. That is fine, right?
Yeah.
Yeah, then no worries. Let's just wait for 2 more minutes for the other people to join as well. There's a couple more people. I'm waiting for them. And we'll start the session by 9:05. It's 9 o'clock right now. We'll start by 9:05. Okay. What did I send the link to? Bhargav, can you hear me? Hello? Other than Monica, there's another person with my name. I'm so sorry. I sent you the link for the instructor. So guys, can you hear me? Who else is there with my name over here other than Monica?
There is 3 Shoaib Ahmed. One is me, another is host, another one is.
Yeah, exactly. Okay, that person just exited. I am the host. So there's Monica, another one. I can't remember who else I sent that link. Monica, tomorrow I'll be sending a new link. Okay, just so that this error doesn't occur. No worries. Okay. Hello. Guys, there's another Shoaib Mohammed other than Monica and me. Who is that? Bhargav, is that you?
Hi, Shoaib. How are you?
Hi, Bhargav.
Hello,
That's
sir,
you,
can you
right?
hear me? Hello.
Hi.
Shoaib, it's me. It's me. Can you hear me?
I can hear you, but is this Bhargav or Gautam?
Yeah, it's this Bhargavan.
Bhargavan. Yeah, okay, Bhargav. The link which I sent you, that was defaultly set for me. That is why your name is as mine. So that is not an issue.
Okay.
Unless and until you can hear me perfectly.
I'll just change that. Yeah. And Shoaib, actually, unfortunately, I'm traveling. Would that be okay? I'll connect tomorrow.
Definitely, not an issue at all.
Yeah. I just wanted to come and say hi. So just
no worries, Bhargav.
Yeah.
Sure.
Okay.
Not an issue.
Thanks. Yeah.
Sure.
Bye.
Bye. Okay, guys. Let's wait for 2 more minutes for the other people to join as well. We'll be starting the session by 9:05. Hi, Madhusudan. Good evening.
Yeah, good evening.
Good evening. Okay, let's wait for 2 minutes more. Okay, guys, let's get started with the session without any further ado. So, one last time confirmation. I hope everyone can hear. Ishwarya, Madhusudan, Monica, and there's another person as well with my name. Gautam, is that you? I guess I've sent you the link as well. Bhargav, have you joined again, or is that someone else? Monica, did you join twice from two devices? This is another
No,
person.
no, no. I joined from only one device.
One device, right? One device, right? Okay, okay. Guys, there's another Muhammad Shoaib. Who is that? Let's just to clear the confusion. Bhargav, is that you, or Gautam, is that you, or who else is this? I have sent that link to a couple students. Okay, anyways, let's keep that out of the way. It doesn't matter anymore. So let's get started. So again, in today's class, guys, this is the first class from the CEH batch, Certified Ethical Hack. And as I've mentioned earlier, these batches start with a few introductory classes. Okay, so we basically need to understand a few networking concepts and basic Linux and Windows commands and the setup of our lab environment. And then we dive into the advanced concepts. Okay, so in today's class, we'll be going with basic networking concepts. So the first thing we need to understand is in a network is what is a host and what is a network. Okay, so a host is nothing but an individual device, guys, an information device which is completely individual. So as an example, your client operating system, your Windows 10 operating system, or your server, or your firewall, or your IDS, IPS, all these individual devices are known as hosts. Okay, now when you have a combination of these hosts which can communicate with one another, a collection of hosts which can communicate with one another, that collection forms a network, guys. Okay. Now these hosts have their own identity, each one among them. Okay, and that identity is called as IP address, where IP stands for Internet Protocol. This was developed by the military in the late 1950s and 60s. There were multiple versions for it. There was IP version 1, IP version 2, IP version 3. These were all quite experimental and failures. What successfully worked out is IP version 4, IPv4. Okay, and that is still intact and still working, for completely functional in today's world also. Okay, so your IPv4 address, IP version 4 address has a few properties. Okay, it is a 32-bit address. Firstly, what I mean by a 32-bit address is that it has continuous 32 bits of data, where each bit is nothing but a value of 0 or 1. And these whole 32 bits are divided into 4 equal portions of 8 bits. And each of that is known as an octet. Okay. And each octet is divided, separated by a dot symbol. Okay. Now, this language that you see over here is the binary language, guys. The numbers of which contain only 0 and 1. And computers primarily talk in binary language only. But for us humans to understand that, it's quite tough. So firstly, let's understand how to convert any binary number to a decimal number. Okay, what we can read. So humans read decimal numbers from 0 to 9. Okay, and computers talk in binary. Okay, but there's an easy calculation to convert any binary number to a decimal number. Let's get with that now. Okay, before that, one small quick recap of basic data formats. You might have heard about this already in your life. You might be familiar with it, but just a quick recap. 1 bit is nothing but a value of 0 or 1. When you combine 8 such bits, that becomes a byte, which is also sometimes called as an octet. Okay, and when you combine 1024 bytes, that becomes a kilobyte. 1024 kilobytes becomes a megabyte. 1024 megabytes becomes a gigabyte. 1024 gigabytes becomes a terabyte. And finally, 1024 terabyte becomes a petabyte. We never come across petabytes. That is usually used in cloud organizations or cloud servers. Okay, now coming back to the conversion. So let's assume I have this whole 32-bit address in binary. What I'm going to do is I'm going to take one octet out of it. So I'll take this first octet, 10101010, and let me write it down over here in an expanded format. Now, once it's written, the first rule to convert any binary number to a decimal number is you write the values from 2 to the power 0 to 2 to the power 7 from right to left. Okay, so the first value is 2 power 0, then you have 2 power 1, 2 power 2, 2 power 3, 2 power 4, and so on up to 2 power 7. Why specifically 2 power? Is because this is binary. You only have 2 possibilities, either a 0 or a 1. Now, anything to the power 0 is always equivalent to 1. So 2 power 0 or infinity to the power 0 is also 1. 2 power 1 is nothing but 2. 2 power 2 is 2 into 2, that is 4. 2 power 3 is 8. 2 power 4 is 16. 2 power 5 is 32. 2 power 6 is 64. and 2 power 7 finally is 128. So it's very important that you remember this basic math values to understand how to convert any number from binary to decimal. Okay, so first rule when you want to convert this number is you multiply this lower number with the top one. So let me just scroll down a bit. Yeah, so again, let me just draw this out. So first thing, you multiply the lower number with the top one, and then you add it with the next one. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 0 plus 2 power 5 into 1 plus 2 power 6 into 0 plus 2 power 7 into 1. This is the main basic calculation. Okay, anything to the power 0 is always equal to 1. So 2 power 0 is 1 into 0, the top value 0, and anything into 0 is 0 itself. Then 2 power 1 into 1 is 2. 2 into 1 is 2. 2 power 2 into 0, again into 0, so that is 0. 2 power 3 into 1, that's 8. 2 power 4 into 0, that's 0. 2 power 5 into 1, that's 32. Oh, sorry, 32. Then 2 power 6 into 0, that's 0. And finally 2 power 7 into 1, that's 128. So when we calculate this out, 128 plus 32 plus 8 plus 2, that is the number 170. So we humans read the number as 170, but the computer understands it as 10101010. It's like on, off, on, off, on, off, on, off signals. Okay. So now that is how you basically convert any binary number to a decimal number, guys. Any questions up to this part? Again, please feel free to interrupt me at any certain point if you have a doubt, and please ask me to repeat if you want me to explain again. Okay, do not hesitate, guys. Any questions or doubts up to this part? Is there any issue with my audio or anything? All fine. Hello, guys.
Yeah, it's good, I think.
Okay, perfect. Now, if so, I would want you to calculate and give me the value for this binary number 01011010. So we have calculated for a different number earlier. I want you to calculate for this and give me the correct answer for it. Again, if you have a pen and a paper beside you, take your time, no hurry, guys, but do the calculation and let me know. Any answers, guys? Anyone? Take your time, no hurry, but do not make any errors if possible. If anyone has an answer, please post it, guys, either in the chat box or via voice as well. Ishwaraya, any answers? Kazi, any answers? Madhusudan, Monica, anyone? Hello.
Yeah, we are on it.
Okay, one of you has said 255. Any other answers, guys? Ishwaraya, any answers from your you have unmuted your mic?
Yeah, I'm just doing.
Yeah, sure. Take your time. No hurry, guys. Okay, but again, just as a simple logic, let me just repeat that. So again, you write down the values from 2 power 0 to 2 power 7. Then you just calculate 2 power 0 into the top value. So 2 power 0 into 0 plus 2 power 1 into 1 plus 2 power 2 into 0 plus 2 power 3 into 1 plus 2 power 4 into 1 plus 2 power 5 into 0 plus 2 power 6 into 1
Yeah.
plus 2 power 7 into 0 finally. Okay. And that would amount to 90.
90.
Exactly. So one of your answers, Madhusudan has given the right answer along with the as well. So again, guys, if there is any confusion, if you're getting a different answer, let me just simplify this as I've mentioned. Just multiply the lower value with the top one and keep adding on. Okay. So 2 power 0 into 0, anything into 0 is 0 itself. Then 2 power 1 into 1, that's 2. 2 power 2 into 0, that's 0 again. 2 power 3 into 1, that's 8. 2 power 4 into 1, that's 16. 2 power 5 into 0, that's 0. 2 power 6, excuse me, 2 power 6 into 1, that's 64. So when you just add this up, 64 plus 16 plus 8 plus 2, you would get the answer as 9. Okay, so your binary number 01011010 is nothing but 90 in the decimal number. Okay, now in a real-time scenario, guys, you would rarely come across a situation where you have to convert any number from binary to decimal. But the reason why I've explained this is so that you understand the range of IP addresses. So if I wanted to get the first IP, all I have to do is put all zeros everywhere. Okay, and when I convert that from binary to decimal, that would be 2 power 0 into 0, 1 into 0, 3, 2 into 0, all the way up to 2 power 7 into 0. So everywhere it's 0. So the first IP is 0.0.0.0. If I wanted to get the last IP, the only possibility is putting all ones everywhere. Okay, so that would be 2 power 0 into 1 plus 2 power 1 into 1 plus 2 power 2 into 1 plus 2 power 3 into 1 plus 2 power 4 into 1 all the way up to 2 power 7 into 1. So that would be 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. If you calculate that out, you get 255. And therefore, the last IP in the IPv4 range is 255.255.255.255. Okay, so this is the range of IPs. And now you logically know as well why the number is only going up to 255 and not exceeding that. So if you ever see an IP like 300.256, that's an invalid IP address. No device will accept it. Okay, IPs can only range between this number and this number. Okay, now let's try to understand the sequence of these IPs. So how many IPs are actually existing from the first IP till the last IP? So to understand the sequence, there are two simple rules, guys. Okay, rule number 1 is always proceed with the rightmost value. So this is my first IP over. Again, ignore these right side values. I'll tell them later why I wrote these. Okay, so for the time being, ignore the right side values, guys. So concentrate only on the left ones. Okay, so this is the first IP. According to rule number 1, always start with the rightmost value. So next IP will be 0001. Next IP 0002. Next IP 0003. Like that, it goes on up to 254, 255. After this, will I have an IP like 000256? Is that possible? Will I have an IP like this, guys, 256? Anyone? Definitely not. Right. Correct.
Yeah.
So,
Yes.
yeah. So after 255 is the final value, the maximum value it can go to. 256 will never come. So once you reach the maximum value over there, then you go to the left value. So only after the rightmost octets have been completely filled, then you go to the left value and reset rightmost value back to 0. So since once this is full, what you have to do is you have to change this 0 to 1 now. Okay, and this 255 becomes 0 again. It cycles back to 0. Now next IP after 0010 is 0011. Okay, don't directly jump to 0020. That would be wrong. According to rule number 1, always start with the rightmost value. So after 0010, next IP will be 0011, 12, 13, 14, 15, 16, like that up to 1255. After that, again, this is maximum. So this 1 now changes to 20. Okay, 20, 21, 22, 23, like that up to 2255. Then 30, 31, 32. Like that, the cycle repeats again and again and again. And somewhere you'll go to 2550, 2551, 2552, 2553, finally 255, 255. Okay, now both these octets have reached the maximum value. Again, same logic. Once the rightmost octets are filled, go to the left value. So this 0 now becomes 1. And this 255, 255 become 0, 0. Guys, is this clear? Any questions up to this part? Am I going too fast? Please let me know. Any doubts up to this part? Kazi, Madhusudan, Ishwar, Monica.
Good from my end.
Perfect. Now, after that, so after 0, oh, 1 second, right? So after 0, 1, 0, 0, then again write most value 0, 1, 0, 1, 0, 1, 0, 2, 0, 1, 0, 3, up to 0, 1, 0, 2, 5, 5. Okay. Now again, maximum value reached. So this 0 now changes to 1. Okay. So 0, 1, 1, 0, then 0, 1, 1, 1, 1, 1, 2, 1, 1, 3, 1, 1, 4, up to 1, 1, 2, 5, 5. Then this 1 again changes to 2. 0, 1, 2, 0, 1, 2, 1, 1, 2, 2, 1, 2, 3. Like that, the cycle repeats again and again, and you go up to 0, 1, 2, 5, 5, 2, 5, 5. Now again, both of them reach maximum value. So this 1 changes to 2. Okay. So whatever cycle repeated from 0, 1, 0, 0 to 0, 1, 2, 5, 5, 2, 5, 5. Same cycle repeats from 0, 2, 0, 0 to 0, 2, 2, 5, 5, 2, 5, 5. Same cycle repeats from 0, 3, 0, 0 to 0, 3, 2, 5, 5, 2, 5, 5. Like that, it goes up to 0, 2, 5, 5, 0, 0 to 0, 2, 5, 5, 2, 5, 5, 2, 5, 5. Now all the 3 octets are filled. Now this 0 changes to 1. Okay. Now like that, whatever cycle repeated from 0, 0, 0, 0 till the last IP 0, 2, 5, 5, 2, 5, 5, 2, 5, 5, the same cycle again repeats from 1, 0, 0, 0 to 1, 2, 5, 5, 2, 5, 5, 2, 5, 5. Again, same cycle repeats from 2, 0, 0, 0 to 2, 2, 5, 5, 2, 5, 5, 2, 5, 5. Like that till the last IP 2, 5, 5, 0, 0, 0 to 2, 5, 5, 2, 5, 5, 2, 5, 5, 2, 5, 5. Okay. Like that, each octet changes 255 times from the first IP till the last IP. So the total number of IPs from the first one to the last one is 255 to the power 4 IPs, which is like 4.3 billion IP addresses in the IPv4 range. Okay. Is this clear, guys? How we got this number 4.3? Because each number is changing 255 times. Okay, and you're getting multiplied with the next octet. So 255 into 255 into 255 into 255. A big number. Not too big, but comparatively when they invented them in 1950s or 60s, it was a huge number. Okay, but fast forward to like into the era of 2021, the population itself is 8 billion people, guys. Okay, and 4.3 billion IPs are nowhere sufficient for that. So that is why they came up with a solution. They converted this 4.3 billion IPs into 2 separate parts. Okay, and that is known as NAT, network address translation. Okay, so with this concept called NAT, they converted these 4.3 billion IPs to public and private IPs. Now, when they thought this solution was also not working out, this even this set is going to expire soon, then they came up with IPv6 addresses. Okay, and IPv6 are 128-bit address. Okay, they are quite very big, 4 times the size in the bit number, but you have trillions and trillions of IPs. Okay, so now we'll discuss what this public and private IPs are. Okay, any questions up to this point, guys? Madhusudan, Monica, Mohammed, Kazi, Ishwaraya. Okay.
Yeah, good.
Right. Now let's discuss what these public and private are. So basically, whenever you connect to the internet, guys, when you want a broadband connection, so when you contact ISPs, internet service providers like Airtel, Tata Docomo, Act, Hibernate, all these people are known as ISPs. Okay, and these people provide you the public IP. So whenever you want to connect to the internet, you need a public IP for that. Okay, so public IPs are the IP addresses provided by your ISP to get access to the internet. Okay, along with that, you have something known as private IPs also. These are the IP addresses that are provided to you locally. Okay, in the intranet, not internet, intranet. Intranet is local network by your DHCP server. So you get it from your DHCP server, or you can manually assign it yourself as the network admin can assign it manually. Okay, so if I just draw this out with a diagram to explain where public IPs and private IPs exist. So let us say this is my router over here. At my home, I have a Wi-Fi router. And to this Wi-Fi router, I'll connect multiple devices. I connect my laptop, I connect my mobile phone, I can connect my smart TV, and so on. Okay, so this router at your home, if you observe carefully, will keep getting a wire from outside your house. So this router gets connected with a wire from outside, and that wire is nothing but the wire from the ISP, internet service provider. Okay, so you could have your own, I mean, you could be connected to any ISP. Examples of ISPs are like Airtel, Act Hibernate, and so on. Okay, so one wire from the ISP comes to your router. And this wire is nothing but your public IP over here. Okay, so let's assume this is something like 1.2.3.4, a public IP. Okay, so this is where the public IP is. Okay, for accessing the internet, and private IPs are over here. These are all the private IPs. So locally in your local network, this could be some IP. So this could be machine 1, this could be machine 2, and this could be machine 3 with their own private IPs. Okay, router also gets a private IP on one of its interface. We'll discuss that later on. Okay, so basically, if I had to give you an example, this could be something like 192.168.1.2. This will be something like 192.168.1.3, and this could be something like 192.168.1.4. Okay, and router also, as I've mentioned, gets a private IP, and that is always the first IP in the network, like 192.168.1.1. Okay, so it has two interfaces. On one interface, it gets the private IP, and on the other interface, it gets the public IP. Okay, and it is acting as a gateway between the private devices. So whenever they want to communicate, they communicate on the private IP port. Okay, and from there, their connection goes to the public IP. Okay, so is this clear, guys? How and where the public and private IPs exist? Now, let me clear this. Can I clear the drawings, guys? Is it okay? Or does anyone want, if anyone wants to take any screenshot also, you can take your screenshots also. Again, you will be provided the recording as well shortly. So shall I clear the drawings? Okay.
Yeah.
Coming to the next part. So now let's try to understand the range of these IP addresses. So your whole IPv4, as I've mentioned, is divided into two categories, public and private. But again, these public and private are also divided into 5 other subcategories, which are known as classes. So if I take this whole big box as the whole IPv4 range, this big box is divided into 5 small boxes. Okay, so just put it over here. This is one box, this is the other one. And then I have 2 other boxes over here. Okay, and each of these boxes is nothing but a class. So you have class A, then you have class B, then you have class C, and then you have class D. Okay, and finally class E over here. And again, each of these classes has public and private IPs. So some part of them in class A, some of them are public IPs, some of them are private IPs, 2 divisions. In class B as well, in class C as well. Okay, in class D and E, there are no private IPs. All of them are just public IPs, special cases. Okay, so this is public and this is also public. There's no division in this. Okay, so now let me write down the ranges, guys. So in networking, this is very important. You will have to memorize these ranges to understand which IP belongs to which class. Okay, so over here, I have written down the ranges. Class A starts at the first IP 0000. Class E ends at the last IP 255, 255, 255, 255. Okay, again, you just have to memorize these guys. They were fixed by the people who invented them by using a concept called parity bit. Now, I won't be going into that much detail, like what a parity bit is. It is not necessary for us as well at the moment. Okay, but just try to remember these 4 numbers. Okay, so class A starts at 0000, ends at 127, 255, 255, 255. If this is ending at this number, the next IP obviously, so this is completely filled. So this 127 changes to 128. Okay, so class B starts at 128,000, goes up to 191, 255, 255, 255. Since this is ending at 191, class C starts at 192,000, goes up to 223. Class D starts at 224. This goes up to 239. Class E starts at 240. Okay, so you have 5 classes over here where these are the ranges of them. Class A starts at 0 up to 127, like that. Okay, one easy method to remember is these 4 numbers: 0 to 127, 128 to 191, 192 to 223, 224 to 239, and 240 to 255. On the left side, you have all even numbers. On the right side, you have all odd numbers. Okay, so these are the classes, guys. Again, in each class, there are 2 other categories, public and private IPs. So let me clear this drawing first. So between this whole range of class A, between 0 to 127, there's a small range 10.0.0.0 to 10.255.255.255. So this is the private IP range. Any IP, excuse me, outside this range by default is a public IP, which is used by ISPs. Similarly, between class B from 128 to 191, there's a small range of 172, 16.0.0 to 172.31.255.255. These are the private IPs in class B. They can be used in your local network. Any IP outside this range is not usable by you. They are provided only by internet service providers. Class C finally, between 122 to 223, there's a small range 122, 168.00 to 192, 168.00 to 192, 168.255.255. These are the private IP ranges. Any IP outside this range is a public IP by default. Okay, so if I take the class A example, guys, just to elaborate this. So if you remember, class A starts at 0000. Okay, and this goes all the way up to 127, 255, 255, 255. Okay, so this is the whole range of class A. Okay, let me just draw this out clearly. So this is the whole class A range. Okay, now in between this class A whole range, there's a smaller range called 10.0.0.0 to 10.255.255.255. That is the private IP range. Okay, so in between these, you have a small value, a small range over here, 10.0.0.0 to 10.255.255.255. Okay, this is the private IP range, smaller range. Now, any IP outside this range will be the public IP. So any IP outside this is nothing but from 0000 to 9.255.255.255. Because after this value, you get the next IP, which is 10.0. Okay, so after 10 to 10.255, this is private. And again, after that, after this last IP 10.255, you will have 11.255. 11.0.0.0. And this goes up to 127, 255, 255, 255. Okay, so this small range is in between the private IP. Outside this range, whatever IPs you see, the rest of them are public IPs. Is this clear, guys? I hope I could elaborate it fine enough. Any questions, guys? If you're not understanding, please let me know now itself, because things are going to get complicated from here. Okay, it's going to get a bit complex. So, Monica, have you understood? Ishwaraya, any questions? Kazi, any questions? Irshad Ali, any questions? Ravila, any questions?
So all these rules are, everyone have to follow, right? So
these are exactly, these are universal, these are predefined, and they will never change for the rest of it. Okay.
So yeah. Okay. So the private IP, right? Private IP range. Suppose if I have two private, networks. Okay. So something like I'm just having questions. So how it is like that. So if my private one is connected to public, right? So if I have two private networks in my maybe lab or my office, right? So
okay,
is it something two different classes, right?
Not necessarily. I'll come back to your question. Ishwaraya, right? Who's asking the question? Ishwaraya only, right?
Yes, yes.
Yeah. Okay. Great question, Ishwaraya. Let me come back to that. One moment before that, just once I'll repeat this concept, okay? Because a couple of students have asked me to repeat this whole thing. So again, guys, as I've mentioned, there are different ranges. Okay. So if you take just the first example, class A, if you understand one range, it is sufficient. You'll understand the rest also. Same logic. Class A starts at this first IP 0000, ends up to 127, 255, 255, 255. And that's the same thing, the same range which I've mentioned over here. This is the whole class A. In between this class A, there's a small range, 10.0.0.0 to 10.255, 255, 255. That will be your private IP range. Okay, so this small range you see over here, this is the private IP. Let me write it down over here. Private. Okay, outside this range, anything, those will be your public IPs again. So again, from here to, let me change the color. So again, from here to here, up to this part. Let me just put it up. Yeah, up to here. Okay, this is the public IP. Similarly, after the private IP again, you have another range over here. From here to here. And this will be another public IP range. As I've mentioned, each class has both public and private. So in class A, this whole range, some IPs in between are the private IPs. Outside those private IP range, any other IP will be a public IP. Okay. So Madhusudan, is this clear for you? You asked me to repeat it once. I hope this is clear now. Right. Okay. Any other person who has not understood this logic, what each class looks like and how in that class the private IP and public IPs look like? Monica, is this clear for you? Hello, guys, are you there? Can you hear me? Qazi Mohammed, can clear for you? Ishwarya, clear for you?
Yeah, clear for me.
Right. Now, coming back to your question, Ishwarya. Okay, you asked me, like, let's say I have two private IP ranges. So to answer your question, no, Monica, you're not audible. Actually, I can't hear you. I can't hear you guys. But anyways, Ishwarya, coming back to your question in the meanwhile. So let me draw this out diagrammatically first. So for you to have two different networks, Ishwarya, you need to have a few special devices. Okay, you have devices like switches and routers. A switch is a device which is used to connect multiple devices in the same network. A router is a device which is used to connect two different networks. Okay, so in our home also, when we have our Wi-Fi router, that router is connecting the internet, the public IP network with a private IP. Okay, so in our local LAN setup, when we have multiple devices like the phones, the mobile phones, the laptops or whatever, all these are private IP devices. These private IPs are communicating with the public IPs with a router in between. Okay.
Right.
Similarly, when you have two different private networks also, these two private networks, when they want to communicate with one another, they need to have a router in between. Okay. Now, as I've mentioned, so this private IPs now, for you to form the network and host, we'll come to that in a small bit, in a meanwhile. But first, let's understand, how do you classify these IPs? How do you judge, how do you distinguish whether which IP is public and which IP is private? I'll come back to your question. But again, as I've mentioned, important point to note, when you have two different networks, whether it be from public to private or private to private as well, if they are two different networks, you always need a router in between to communicate. Okay. Right. Now, Monica, you also had a query. Can you please ask me in the chat box, because you're not audible.
Am I audible now?
Now you're audible. Yes, I can hear you.
I have one query. Suppose my system has a private IP addresses, so I can change my private system IP addresses, right?
Definitely.
Yeah. So if I provide my system IP addresses with like 240.0.0.0, so this can be would be like public IP addresses, or like still this is for like private IP address.
Again, as I've mentioned, when you're saying 240.0.0.0, this belongs to class E. And in class E, you do not have any private IP. Private IPs are only existing in class A, B, and C. So you can only provide an IP in these ranges. Okay.
So like
class
I
D and
cannot
class
change the IP of my system IP address with this like 240.0.0.0.
You can't. You cannot. Class D and class E do not have private IPs, and you cannot assign your system any IP in that range. Only and only you can assign them in these three ranges. Okay. Class A, B, and C. Okay. Right, guys. Now, just to clear out these confusions, if any are left out, let me clear these drawings first. Now, I just write down 10 random IPs, guys, over here. And I want you to tell me by looking at the table on the top, which IP belongs to which range or so. Okay. 1 second, let me clear all this out. Okay, so you can look at these ranges.
I have one more query. We can access like one like suppose I can access one system to another system like through the IP addresses, or I can trace like, so can I get access for the public IP addresses with their address?
Sorry. Please come again. I didn't get your point. So you can set an IP yourself, which is a private IP. So if you have your laptop, you can give that laptop a private IP.
No. Suppose I have a server, server
Okay.
A and server B. So I can like get access from server A to server B, right? These are both are the private IP addresses. Okay, and there is server C, which is which has a public IP address. So can I get access for the private to public IP addresses like server A? Can I connect a server C from the server A?
Server C from server A. Server A has private IP, server C has public IP.
Public IP address.
Okay. When you're talking again, simple logic to understand over there, Monica, is whenever you're talking about public IP, it is always on the internet. Okay. So if your server A and server C also are getting a public IP and access a method to connect to the internet. So let's say the server A and server B are also getting are connected to a router in their local network, and that router is connected from an ISP connection. Then they can connect to server C also. If you're the server A and server B do not have a way of connecting to the internet, they cannot communicate with this server C. Simple. Okay. So let's say I have my, you don't need to take servers also. Let's say I have two devices in my local network at my home. I have my mobile phone and I have my laptop. Okay. And each of these is getting a private IP. And on the internet, there's google.com, a public IP.
So suppose these all servers are for on the cloud. So suppose like
then definitely, when you're talking about cloud, the server A and server B also have internet connection. So they can communicate with the server C, definitely. Okay. So as I've mentioned, simple methodology to understand is if you're connected to the internet, you can connect to any public IP. Okay. So when you're talking about cloud now, definitely you can connect this private IP to the public IP because in cloud, everything is interconnected. Okay. The example which I was giving was, let's say I had two devices like my laptop and my phone in my local network. Okay. And I have a public server like google.com. For me to now connect to google.com, these two devices need to be connected to internet in some way. So I need to either connect my device to a Wi-Fi router, which has an active internet connection, or I have to give them some mobile data or whatever it be. Okay. Unless and until these two devices have a method to connect to a public network, they can't access that Google server. Okay. Now in cloud, your scenario was different. In cloud, they can easily access because on cloud, everything is connected to the internet.
Okay.
Right. Now, let me just write down a few random IPs. Please look at the ranges over here and tell me which IP belongs to which class and which range also, whether it's a public or private IP. So give me 2 minutes. Let me write down just some random IPs. And then, okay. Okay, guys. Yeah, I'm done. I've written down 10 IPs. I want you to look at each IP and first tell me which class it belongs to. Okay, so you tell me which class it falls under, and then when you tell me whether it's public or a private. Okay. Private, correct answer. But which class, guys? First the class.
Class A.
Class A.
Perfect. And public or private?
Private.
Private, correct answer. Because this is falling under this range between 10.0.0.0 and 10.255.255.255. Correct answer. Now, what about this one? Oh, sorry.
Class C.
Class C public.
Okay, perfect. Class C and public. The reason being, this is 170. Okay, 170 is outside this 168 range. So correct answer. Next one.
Class E public.
Class E, perfect, and public. Okay, because in Class E there are no private addresses, so this is public. Next one.
Class B private.
Class B. Are you sure it is private?
170 to 20, right? So between 16 and 31.
Right, correct. Just trying to confuse you. Just trying to trick you. Correct answer. Okay, don't get confused, guys. Next answer.
Class A public.
Right, Class A public. Perfect, Monica. And the other person who's answering is Ishwarya, right? Yeah, Ishwarya. Yeah, correct answer, Ishwarya. Okay. Next one, 1 second, let me just sort this out properly. I don't. Yep. So this one now, 192.168.21.1.
Class C,
Class C,
private.
private. Perfect answer. Next one,
Class C, public.
public. Correct. Next one,
26. So class D,
class D, right?
226, right? Yeah, public.
Public. Because class D and class E have no private IPs, guys. Okay.
So 12,
Next
yeah.
one,
12 means class A, public.
class A. Okay. Are you
No,
sure it is
no, no,
public?
no.
Private.
Class A, private.
Private,
So
private.
it's only 10, right? So it is not 12 then public.
Okay. How many of you saying this is private and how many of you saying this is public?
Private, Monica.
Private, Monica.
Second one, 10.
Any other
Okay,
answer?
okay. Private.
Are you sure?
Yeah, sure.
Starting with 12 means public.
It's public
not-
IP, guys.
yeah.
It's not private, it's public because this is 12. Okay. And private is only from 10.0.0.0 to 10.255.255.255.
Yeah.
I have written 10 on the last octets. If you clearly observe, I usually do this just to confuse you. Okay.
Mhm.
But if you observe, this is 12. And when in class A, the first octet 12 is falling outside this range. Okay. So 12 is going to come after 10.255.255.255. After that, you have 11 and then you have 12, which is outside the private range. So this is public. Monica, I hope this is clear.
Yeah, clear.
Right. Now, last IP, 172.35.
Class B,
Yeah, class B, correct. Class B,
35 means public.
public. Yeah, definitely. Because this is after 31. Okay, outside 31. So that's a public IP. Correct answer, guys. Again, we have done this with the reference of these 8 lines of data. My recommendation to you, the earliest you learn this 8 lines of data, networking is going to get that easier for you. Okay. So as soon as you look at an IP, so if I go to my browser, in the browser, I can check my public IP. All I have to do is search for what is my IP. And this shows me my public. Now, do not get confused. What is this one? This is an IPv6 address. This is how your IPv6 looks like. But if you want to see your IPv4, select any of these websites. And this will show me my IPv4 also. So just a minute. And as you can see, this is my IPv4, which I'm getting from my ISP Airtel. Okay. Now, can you look at this IP and tell me which class it belongs to? 106.212. something.
106 means class A.
Right. It's class A. Okay. And definitely it's outside this range. 106 is outside. Therefore, that's a public IP. If you want to check your private IP now, so you can just have to go to command prompt. Okay. And in the command prompt, you just give the command ipconfig, which stands for IP configurations. Okay. And once you hit enter, this shows you the multiple interfaces that you have, the Ethernet and whatnot. Since I'm connected to my Wi-Fi right now, as you can see, so I have to check my wireless interface. Okay. And in the wireless interface, my IPv4 address is 192.168.1.6. Now, can you look at this IP and tell me which class it belongs to?
Class C.
Class
Class.
C, private.
Right. And you can notice it is falling inside this range. Okay. So this is how you classify and understand which IP is what and where it belongs to. Okay. So one last thing now I want to discuss before I end the session today is asking you how many networks are existing in each of these. So we know. Oh, no, one second, guys. We did not come to the networks part. One second. Yeah. So now, Ishwarya, this will resolve your question. Like I have 2 networks. That was the part. So now coming to this. So each of these private IPs, in any private IP, you have networks again. So public IPs are used for connections, okay, for internet connections. Private IPs are not like that. Private IPs are used to form a network. So in your home, when you have a router and other devices, your phones, your laptop, your smart TV, whatever it be, all these devices are interconnected with the private IPs. Okay. So these private IPs have something called as network and host portions. Okay. So class A has 1 network portion and 3 host portions. Class B has 2 network portions and 2 host portions. Class C has 3 network portions and 1 host portion. Class D and Class E, since they have no private IPs, they are not used to form networks. they are all network portions on. Okay, so as you're progressing down, you can see network portions are increasing. Okay, 1 network portion, 2 network portion, and 3 network portions, and 1 host. Now, what are these network portions and what are these host portions? So to explain that, let's take the example of class C first. So I take the class C IP range 192.168.00, the first IP. Okay, so in class C, if you remember, I told you there are 3 network portions and 1 host portion. Okay, so if this is the first IP 192.168.00, next IP is 192.168.01, next IP 02, next IP 03, next IP 04, next IP 05. Like that, it goes up to 0255 maximum. Okay, now once this maximum 255 has reached, then what happens? The 0 now changes to 1. So you have 192.168.1.0, 1.1, 1.2 up to 1.255. Okay, now what I mean by this network and host portions is that as long as the host portion changes, it doesn't matter. Each of these is just an individual host device. So this could be my router, this could be my mobile phone, this could be my laptop, this could be my smart TV, whatever. Okay, but as soon as any network portion changes, so once this 0 value changes from 0 to 1, the network divides over there. Okay, so now all these devices belong to one single network, all these devices belong to another network, and they can't communicate with one another. So all these devices you can connect in a switch, and you can connect these in a different switch. But if you want these to communicate in between, there needs to be a router over here. Okay, is this clear, guys? So a network is where all the devices can communicate with one another, and they will only communicate when the network portions are matching. Okay, as soon as the network portion changes from one to the other value, the network divides over there. Okay, is this clear? Ishwarya?
Yeah.
Right. I hope this was what your question was, if I'm not wrong. Okay, so you were saying that you have 2 different networks like these. Okay, and what was that after that? What was the question after that?
How to maintain these IP addresses, right, in these 2 private things, so to communicate each other. So here you were explaining that it needs to match the network and the host, right?
Portion,
so
exactly.
Yeah.
Right. So again, so if you have multiple devices over here, let me just quickly draw this out. Okay, so let's say this is device 1, device 2, and device 3. Okay, and these devices have some IPs like 192.168.0.10. This is 192.168.0.20, and let's say this is 192.168.0.30. Okay, now these devices can communicate with one another because they belong to the same network. Now, let's say you have another 3 devices similarly. Okay, but these devices have different IPs again. So this could be something like 192.168.1.10. Let's say this is 192.168.2.10, and let's say this is 192.168. Oh no, sorry. 1 second, guys. Let me revert. This is 192.168.1.20, and this is 1.30. Okay, 192.168.1.30. Okay, now these 3 devices can communicate with one another. They form one single network like this. Okay, and these 3 devices form another network. But now if you want these 2 devices to communicate with one another, you need to have a router over here. Okay, and the router will allow the communication between this network and this network. Okay, so router also has its interfaces, and on one interface it will get this network IP. So this will get, on one side it will be like 192.168.0.1, and on the other side, on the other interface, it will be like 192.168.1.1. Okay, so this 1.1 interface can communicate with these devices. The 0.1 interface can communicate with these devices, and that is how a router will allow traffic from one network to the other network. Okay, I guess this was your question, Ishwarya.
Yes, I got some extent. Yeah.
Right. I hope this doubt is clarifying things for others also, guys. Madhusudan, Monica. There's another person, Shoaib Ahmed. I don't know who that is until now. Who is that, guys? Can you please name out yourself? Other than Ishwarya, Monica, and Madhusudan, who is the 4th student?
Yeah, sure, this is Rabbani.
Oh, Rabbani, I completely forgot I sent you the link. Yeah, sorry. Again,
Yeah, no
I
problem.
sent the link with my name, so I'll change that link and send you another one, new one. So Rabbani, any questions for you on your up to this part?
No, it's clear. It's clear. Yeah.
Okay, guys. So yeah, let's end the session over here, guys. It's almost around 10. So again, the most of the part is done for networking. We have small concepts left out, and we'll discuss that in tomorrow's session. Okay. Again, I have recorded this session, but I'll be sharing it from Monday onwards. We'll share the recordings, guys. We need to initiate payments. So once the payments and all are clarified and done, I'll be sharing the recordings as well from Monday onwards. Okay. Well, we just need the confirmation on the payments and all. So I hope that's okay.
So can we expect questions in this concept, this certification exam?
Basic, yeah, like very rare, but at least 1 or 2 questions will be asked from the networking part as well. Okay, not many. So out of the 125 questions in CEH exam, 1 or 2 questions will be asked from network. This is very basic concept. So you can only expect max 1 only, not more than that. Okay. Right. So yeah, one last thing, guys, please share me all your email addresses in the chat box so that I can send you this notepad file and you can refer the notepad file later on. So please send me your email addresses, everyone.
Shoaib, you have my email, right? Can I send it
Rabbani, yeah, I should be having those. 1 second, let me just check it out. Yep, I've got that.
this one,
Yeah. Ishwarya, Madhusudan, and Monica, please share your emails. I'll send the notepad file.
Shared on chat.
Oh yeah, got it, Monica. Thank you. Okay, Madhusudan, got your email as well. Ishwarya, your email is one is missing. That's it. Nine PM batch, right? Okay, guys. Yeah, I've sent you the link. You can please check that. I've sent you the notepad file. Please go through it if time permits tomorrow. And tomorrow we'll continue from where we left off exactly. Okay. So yeah, thank you guys. Have a good day tomorrow and good night. I'll see you tomorrow. Bye-bye.
Thank you, Shoaib. Thanks. Bye-bye.
Thank you guys. Bye-bye. Bye-bye.